Hello everyone, welcome back to the channel. In this video, we are going to take a look at proving this limit. And this is a limit I was working on just to do some practice, and it was surprisingly a little bit more tricky than I thought it was going to be. So I figured I'd go ahead and make a video and do a walkthrough of it. So the way I like to do my proofs, my delta-epsilon proofs, is I like to work out the values of delta before I write the proof. So before we even get started with the proof itself, what I'm going to do is I'm going to try and find these values, okay? So using the definition of the limit, the delta-epsilon definition, we're going to do, that's not the color I chose. We are going to do 0 is less than the absolute value of x minus a, which is less than delta. So this would imply that the absolute value of f of x minus L is less than epsilon. Now, remember, we're not writing the proof right now. We're just doing some scratch work. So I'm going to say this is all scratch work. Okay. So that means I don't have to say things like A is equal to this, L is equal to that, given epsilon greater than 0. So because we're not doing the proof yet, I'm simply working on finding the values of delta. Okay. So how are we going to do this? Well, let's go ahead and plug in our values over here. So we're going to have x minus a is going to be 2/3 is less than delta. And over here on the right, I'm going to go ahead and substitute the values for f of x and L. So we're going to have the absolute value of negative 9 x squared minus negative 4 is less than epsilon. Okay. So this is f of x, this is L, and this piece is a. All right. All right. So from here, what I'm going to do is I want to work this side. I want to work this side down until I can get it into this form right here. Then once I can find this form over here, then I know that whatever is going to be on this side of the inequality will be our delta. That's what we'd like, right? So let's go ahead and start manipulating this and working down. So looking at this, let's go ahead and just do some simplification inside, and we can see that this is going to be the absolute value of negative 9x squared plus 4 is less than epsilon. Now I'm going to write, I'll probably have a lot more steps than you may like or want, but I want everything to be very clear, okay? So I'm going to go ahead and factor out an absolute value of negative 4. So absolute value of negative 4 times the absolute value of, so this becomes a positive 9/4 x squared minus 1 is less than epsilon. Now, this is going to be important later on, so I'm just going to go ahead and make a note of it right now, which I may note it again or recall it again. Note, the absolute value of negative 4 is equal to the absolute value of 4, which is equal to 4, okay? So what I'm going to do is, now again, I'm writing a whole bunch of extra steps so this is clear. I'm going to rewrite this side, but I'm going to go ahead and multiply. Well, here, I'm just going to rewrite this side first as this. So this is times 4, all right? Now, I'm going to multiply both sides by 1 over 4. So then we're going to say 1 over 4 times 1 over 4. Now, because this is, we're not dealing with matrices and we know that things are commutative right now, I can do a left side multiplication on one side and a right side multiplication on the other. We don't have to worry about that when we're doing this. So if we did have to worry about that, then over here, this would be 1/4 times epsilon, right? So that is going to cancel the 4 on this side, and we're going to be left with 9 over 4 x squared minus 1 is less than epsilon over 4. Now, if you haven't recognized it yet, inside this absolute value, we have a difference of 2 squares, okay? So this can be rewritten as 3 halves x squared minus 1 squared is less than epsilon over 4. Now with this, we are going to go ahead and factor this using the difference of 2 squares formula. And with that, we end up with the absolute value of, excuse me, 3 halves x plus 1 times 3 halves x minus 1, which is less than epsilon over 4. Now, we're trying to work this down to get into this form, right? So, and that's the only thing on the left side is going to be this x minus 2/3. So let's keep going. So what I'm going to do next is I'm going to factor a 3 halves out of both this binomial and this binomial, all right? So when I first did this, I made the mistake and I just pulled 3 halves out and only one set of 3 halves. But that doesn't allow you to take 3 halves out of both, and that was the mistake that I made at first. So I'm going to be pulling out a factor of 3 halves. So that's going to be the absolute value, 3 halves, times x plus 2/3 times 3 halves times x minus 2/3, which is less than epsilon over 4. All right, so now we have this factor of x minus 2/3 in there. So now we just need to solve for it, and then we can start working with choosing our deltas. So we can pull this 3 halves out. That becomes 9/4. So we can write this as 9 over 4 times the absolute value of x plus 2/3 times x minus 2/3 is less than epsilon over 4. Now, for this proof, you need to keep track of all of your numerical constants that you're pulling out, because when you start canceling them, you need to know how to go backwards when you start doing the proof, okay? So you'll see what I'm talking about when we get to that point. So right now, I'm going to multiply both sides by 4 over 9. So that's going to cancel this side. And then we have the absolute value of x plus 2/3 times x minus 2/3 is less than 4 times epsilon over 4 times 9. Okay. So yes, you can do this cancellation here, but I would say just keep a note of this before you do the cancellation, right? So just be sure you know where to find that in your proof. So that's going to be equal to epsilon over 9, okay? So the next thing that we're going to do is we are going to separate this absolute value. So we're going to say the absolute value of x plus 2 over 3 times the absolute value of x minus 2 over 3 is less than epsilon over 9. So here we are going to divide both sides by the absolute value of x plus 2 over 3. With that, we get x minus 2 over 3, the absolute value of x minus 2 over 3 is less than, so I'm going to write it like this, 9 times the absolute value of x plus 2 over 3. So in the denominator, and then epsilon on top. I write it like that because it's easier to figure out how your denominator is going to fit. Excuse me. Okay, so now we have this term, this delta. We have this, but we have a problem. This, saying this is equal to our delta, we can't let our delta be defined in terms of x. So we need to come over here and we need to figure out what x plus 2/3 is. Like we need to get a value for that, okay? So we can restrict it. We want to limit that, that value. So let's choose. We're going to make a choice. Choose delta equal to 1, okay? Now, when we do this, what we want to do is we want to manipulate this thing on the left into an x plus 2/3, okay? Because that's what we have down here, x plus 2/3. So we want to manipulate that into an x plus 2/3 and then find a value for what that is, okay? So we're going to say x minus, the absolute value of x minus 2/3 is less than 1, which we can rewrite this as -1 is less than the absolute value of, I'm sorry, got distracted by the beeping. -1 is less than, we drop the absolute value, is less than x minus 2/3, which is less than 1. Now, we want a plus 2/3 in the middle of this inequality statement, right? So I'm going to add plus 4/3 to everything. Okay, so on the left-hand side, -1 can be rewritten as -3 over 3. So -3 over 3 plus 4 over 3 is going to be 1 over 3. Is going to be less than, and then -2 over 3 plus 4 over 3 is going to be equal to plus x plus 2 over 3, which is what we want, which is less than 1 is 3 over 3, so 3 plus 4 is 7. So this is 7 over 3. Now this is where you need to figure out how to make this back into an absolute value. So this, the left-hand side of this inequality chain is not the same as the right. And it's not the negative of the right-hand side is what I meant to say. So let's go ahead and draw a number line to kind of showcase what's going on here. Now it's not going to be very fancy, but what I want to show is let's have 0, let's have 1/3, and then let's have 7/3, and then let's do -1/3 and -7/3. Okay. Now, what the statement we have right now puts x plus 2 over thirds from here to here, okay? Not including the endpoints, right? But if x plus 2 over thirds is in between there, then wouldn't it also be safe to say that it is between here and here? Let me go ahead and draw that underneath. Wouldn't it be safe to say that it is between seven thirds and negative 7/3? It is. You can say that. So x plus 2/3, based on the inequality that we have, okay, is in between here. But if it's in between there, then it's also going to be in between here, okay? So let's go ahead and rewrite this inequality as negative 7/3 is less than x plus 2/3, which is less than 7/3. And then now we can rewrite this as an absolute value. So we have the absolute value of x plus 2/3 is less than 7/3. Okay, cool. So this is what we have over here and what we found to be our delta statement, okay? So then what we can say is that because this x plus 2 over thirds is less than 7 over thirds, then we can rewrite. So what we're going to do is we're going to rewrite this as the absolute value of x minus 2/3 is less than epsilon over 9 times 7/3. Okay. Now also you want to remember this statement as well, okay? Because we're going to have to work all this backwards in the proof. So this ends up becoming, you get this is 3, so that goes once, and that goes 3 times. So this is going to be equal to epsilon over 21, which is 3 times 7. So what we find is that the other delta is going to be absolute value of x minus 2/3 is less than epsilon over 21, which is going to be equal to our other delta. All right. Now, what I would recommend is that you go back and you check this value. You work it back through before you start writing your proof. You're going to be doing double the work, but you're not going to get almost all the way through your proof and find that this value doesn't work if you work it out the first time. So I've already worked it out, so I'm not going to work this back out before I write the proof, because I'm going to work it out in the proof, and you'll see what I mean. So that means that here we chose delta to equal 1, and then over here we found delta is equal to epsilon over 21. So that means what we're going to say in the proof is we're going to let delta equal the minimum of 1 or epsilon over 21. Okay? Now, let's go ahead and start on the proof. So this is going to be the proof. Oh, wait, before we get started, let me just go ahead and do this. Let me make a note of this really quick. So epsilon over 21. Let me zoom back in so it can all be within the same size. So epsilon over 21. Now, all these cancellations that were made, I'm going to go ahead and write down what those are without doing any of the cancellations. That way, I don't have to go back and search through because I had to do this when I worked the proof originally. So this is what this is equal to. 4 times epsilon over 4 times 9 times 7 over 3 in the denominator, okay? So just keep that in mind because we're going to come back to that. And now we are ready to start the proof. Okay, so the first thing we're going to do is we're going to say, let f of x equal negative 9x squared, and then we're defining a is equal to negative, I'm sorry, not negative 2/3, my bad. A is equal to 2/3. And L is equal to negative 4. Okay. Next. So there we're setting the stage. We're identifying what everything is that we're going to be using in our proof for now. So the next thing we want to say is, given that epsilon is greater than 0, let delta be equal to the minimum, so the least value between these two of 1 and epsilon over 21. So the very moment that epsilon grows larger than 21, your proof will revert back to 1, okay? That's what's happening here. Okay, then we want to select an x value such that 0 is less than x minus a is less than delta, implies, 0 is less than the absolute value of x minus a, which is less than delta, implies the absolute value of f of x minus L is less than epsilon, okay? So the next step, if we didn't have two terms for delta, we would simply start with the 0 is less than x minus a, 0 is less than the absolute value of x minus a, which is less than delta, and we would derive out the absolute value of f of x minus L, which is less than epsilon. But we need to show the case in our proof for delta equals 1, which limits our value for the absolute value of x plus 2/3, okay? So next what we're going to do is say, for delta equal to 1, the absolute value of x minus 2/3 is less than 1. Okay? Now, just as we did up here in all of this stuff here, we need to do this. We don't have to show as much work if we don't want to, but we need to get this result of 7/3. We need to show this result in the proof, okay? So we are going to say -1 is less than x minus 2/3, which is less than 1. When I add 4/3 to both sides, you end up with a 1/3 is less than x plus 2/3, which is less than 7/3, and then this implies that it also falls into this range. Which then implies that the absolute value of x plus 2/3 is less than 7/3. Okay? So we need this, all right? So next, what we're going to do is we are going to say, we're going to do the case for delta equals epsilon over 21. For delta equals epsilon over 21, not note, but recall that epsilon over 21 is equal to this 4 times epsilon over 4 times 9 times 7/3, okay? So we are going to start with x minus 2/3 is less than delta, and I'm going to use this form right here, okay? Which is equal to 4 times epsilon over 4 times 9 times 7/3. And then what I'm going to do is I am going to multiply this 7/3. I'm going to multiply that by both. I'm going to do these steps one at a time so we can see them. So I'm going to multiply it by 7/3 here, and then 7/3 here, all right? So then that results in 7/3 times the absolute value, let me just write it like this, times the absolute value of x minus 2/3, which is less than, so over here on this side, this cancels with this. So this is less than 4 times epsilon over 4 times 9. But this 7/3 we know is going to be, is greater than the x plus 2/3. So if we wanted to write it, we could write it as the next step. We can go ahead and I'm just going to write the next step and I'll explain it. So 7/3 we're going to replace with the absolute value of x plus 2/3. So then we have x plus 2/3 times x minus 2/3. And this is less than. So here we could put less than, we could put this statement right here, and then do less than this statement here, all right? But there's no need to do that. That's just extra work. That's just not, you don't need to show that, okay? So then we're going to have 4 times epsilon over 4 times 9. But I want to rewrite that as, I'm going to go ahead and rewrite that as 1 over 4 times 4 over 9 times epsilon. And you'll see why in a second. So on the next line down, what I'm going to do is I want to get this epsilon by itself on the right-hand side. So we're going to have x plus the absolute value of x plus 2/3 times the absolute value of x minus 2/3 is less than. Now, I need to multiply this right-hand side by the reciprocal of everything except for that epsilon. So I want to multiply it by a 9 over 4. and a 4 over 1. And that's going to be all multiplied by 1/4 times 4/9, which was our original, times epsilon. And then on the left-hand side of our inequality, we're also going to multiply by this thing as well. So it's going to be 9 over 4 and 4 over 1. The order doesn't matter here as far as the multiplication goes because it's commutative, right? But this order is important for making this problem easier to solve, okay? So on this right-hand side, this cancels with this, and then we have this cancels this. So we are left with 4 over 1 times 9 over 4. Now, I know this is a lot of extra steps of rewriting this stuff, but I just want it to be clear before we move forward. X. So let's go ahead and combine these this multiplication of these binomials in absolute value into the absolute value. Okay, so this is going to be the absolute value of x plus 2/3 times times x minus 2/3, all inside the absolute value, less than epsilon. So that's good. We're back to epsilon on the right-hand side of our inequality. So the next step is, remember when we pulled this out, we pulled it out as two different terms of 3/2. So let's go ahead and separate that. So we're going to have 4 times 3/2 times 3/2. Again, you don't have to do this many steps. I am, just to make it all clear. Times the absolute value of x plus 2/3 times x minus 2/3, which is less than epsilon. Now I'm going to multiply one of these 2/3 by this one, by this binomial, and the other one by this binomial. It doesn't matter which one, just, they each go to their own. You don't want to put both terms into just one of them. You can if you want, but I'm just literally doing everything in the reverse order that we did to get to our terms up here, right? I'm just doing the reverse of this. So we are going to have 4 times the absolute value of 3/2 times x plus 2/3 times 3/2 times x minus 2/3 is less than epsilon. Now we multiply these constants into our binomials, and we get 4 times the absolute value of 3/2 x plus 1 times 3/2 x minus 1 is less than epsilon. Now, let's go ahead and perform this FOIL operation of multiplying these two binomials together. So this is the result of a difference of 2 squared. So if you know the formula, you can just easily rewrite this as 4 times the absolute value of 9 over 4x squared minus 1, which is less than epsilon. Okay, so one more thing to recall. So recall 4 is equal to the absolute value of 4, which is equal to the absolute value of -4. So then let's go ahead and make this substitution. Again, we're going to use -4. So let's go ahead and replace 4 -4, and then we have absolute value of -4 times the absolute value of 9 over 4 x squared times x squared minus 1 is less than epsilon. Now let's go ahead and distribute this -4 inside this absolute value of -4 inside the other absolute value with the binomial in it. And we get 9/4 times -4 is going to be -9x squared plus 4, which is less than epsilon. I'm sorry, the absolute value of -9x squared plus 4 is less than epsilon. And then we have one more step to do before it looks like it's in the correct way. So we just rewrite this plus as the subtraction of a negative. So we have the absolute value of -9x squared minus -4 is less than epsilon. Now recall from earlier, this is our f of x, this is our L. So then the last thing that we have to do, oh, sorry, one second, we're not done yet. So then I'm just going to rewrite this as f of x, which is the same as f of x minus L, is less than epsilon. And then the very last step is to say therefore, or thus, the limit as x approaches 2/3 of -9x squared is equal to -4. And that's it. You're done. So the proof part is just this piece right here. Okay. Now, you can, depending on how much you are willing to omit. So let me zoom in a little more. All right. So you may be able to omit some of these intermediate steps, but you need to have enough that the reader can follow along. It just depends on who you're talking to, right? And then down here in all of this, you can omit quite a few of these steps because this is me just showing you step by step and rewriting it a lot to where it's clean, right, on the next line down. So you can omit quite a few of these steps in your proof to make it shorter. But I just wanted to show you all of the steps. That way everything was clear. So again, the first thing that we did was the scratch work, right? We had to find our deltas. And then once we found our deltas, we can start writing the proof. Now keep in mind, I worked through, let me see. So all of this right here, I worked through in my scratch work when I worked this out on my own without recording it the first time through, just to make sure that I was able to get back to the absolute value of f of x minus L is less than epsilon. Because you don't want to get into the part of your proof where you're this far down and then find out that the delta you chose doesn't work. So I actually worked all that out on the side, and then I'm showing you just this work in here in the proof, right? So that I already did once before just to double check. And again, this right here, remember this piece right here, right? If you just cancel things out and you don't keep track of them, then when it gets time to work back through everything, because essentially what you're doing is you're starting with this f of x minus L, and you're working this right here, and you're working backwards to find this statement, right? So what you're trying to do with that is then once you can find that statement, then in your proof, you can work the implication, right? So you can work the P implies Q from that implication, but working backwards helps you figure out where to start from, okay? It helps you find your deltas. So with that said, I hope that this was informative. I hope that, this was clear. If it's not, let me know where it was confusing. If you have a better way of working this proof, by all means, feel free to send me a link or a screenshot at the channel's email. And If you see any mistakes or errors, by all means, let me know. I don't think there are because we were able to get back to where we wanted to get back to. But if there is an issue, please let me know and I will rework this out and acknowledge that I made a mistake. So let me know what you think. And if you have any suggestions, comments, concerns, feel free to leave them down in the comment section. And with that, I will let you go. Have a good day.